Polymorphism. Another object-oriented concept we'll look at is polymorphism, and all that means is the ability to take on many different forms. Now, polymorphism can apply to objects, and it can also apply to operations. Let's look at some examples to see how. A polymorphic object is one whose true type hides within a superclass. As an example, think of the class basketball player. Now, this class has different subtypes: center, forward, and guard, and each of those subtypes has its own idiosyncrasies, position, rules, strategies for play. However, when we're talking about the operation dribble ball, that operation is the same for each of those subtypes. So when you're talking about the dribble ball operation, you want to refer exclusively to the generalized class of basketball player. Then when the operation of dribble ball is executed, the basketball player object will take on one of several forms. Now, the flip side of that is a polymorphic operation. In a polymorphic operation, the operation may be carried out in different ways based on the class of the object that's doing the operation. In other words, polymorphism allows you to treat derived class members in the same way as their parents' class members. This lets objects of different types respond to the method calls of the same method, with each object responding with the appropriate behavior for its type. So for our example here, we have two types of the animal class. We have a dog and we have a fish. And if we're talking about the polymorphic operation breathe, at runtime, the breathe operation will be performed differently by the fish, breathing water through its gills and producing bubbles, than it will by the dog that will breathe air and pant.